Ever notice that small number glowing on the in-flight screen, somewhere around 35,000 feet, and wondered, why there? Why not 20,000 or 50,000? It looks so random, yet it's one of the most deliberate decisions in modern engineering. Every flight you take, every mile crossed, every drop of fuel burned is planned around that altitude. It's not just a number, it's the invisible line where science, economics, and human survival meet. This isn't about guesswork or pilot preference, it's the product of decades of research, calculations, and trial by turbulence. At 35,000 feet, the laws of physics quietly cooperate with the demands of efficiency, safety, and comfort to make commercial flight possible, and once you understand why, you'll never look at that cruising altitude the same way again. Airlines aren't obsessed with altitude, they're obsessed with efficiency. Every foot a plane climbs is calculated to squeeze the most distance from every drop of fuel. Down near the surface, air is thick and heavy, packed with molecules that push back against the wings. It's like running through water instead of air. The higher you go, the thinner that resistance becomes. At 35,000 feet, drag drops dramatically, and engines can finally breathe in a balance of air that keeps them powerful yet economical. Flying any lower would waste thousands of gallons of fuel, while going too high would push engines past their limits. This altitude is where aerodynamics, fuel burn, and speed all hit their perfect rhythm, where airlines save millions by simply riding the edge of the sky. If flying higher saves fuel, why not just soar to 45,000 or even 50,000 feet? Because jet engines have their own breaking point. A jet engine is a hungry machine. It needs oxygen to burn fuel. The higher it climbs, the less oxygen it gets. Beyond a certain altitude, the air becomes too thin to sustain efficient combustion and thrust begins to collapse. Engineers call this the service ceiling, the maximum height where an aircraft can safely maintain speed and control. For most commercial jets, that ceiling sits around 40,000 to 45,000 feet. Above that, the engines can't breathe well enough to keep the plane aloft. So 35,000 feet becomes the sweet spot, high enough to reduce drag, low enough for engines to still roar efficiently. It's the invisible compromise that keeps your flight smooth, fast, and safe. You might not notice it, but at 35,000 feet, you're flying above the weather itself. Most turbulence, storms, and unstable air currents live in the lower layer of the atmosphere, the troposphere, which tops out around 30,000 to 40,000 feet. By staying near the upper edge of this layer, pilots dodge the worst of it. That's why flights are smoother at cruising altitude, even when lightning flashes below. Pilots constantly monitor radar data and adjust a few thousand feet higher or lower to find calm air, a process called turbulence avoidance. This altitude isn't just about efficiency, it's about passenger experience. The fewer bumps passengers feel, the more confident they remain in the machine carrying them across continents. Flying high keeps you out of chaos and inside a bubble of engineered calm. Thousands of planes streak across the sky every hour, and somehow they never collide. The secret lies in flight levels. Invisible highways managed by air traffic control. Eastbound planes cruise at odd altitudes, 33,000, 35,000, 37,000, while westbound flights use even ones like 34,000 or 36,000. Each altitude acts like a separate lane in a vertical skyscraper of airspace, separated by just 1,000 feet. This layered system ensures safety, even when two jets pass within seconds of each other. Over oceans, planes follow fixed corridors called tracks, where separation and precision are even tighter. Without these altitude rules, the modern sky would be chaos. So next time you glance at the flight map, realize that your plane isn't just flying, it's cruising through an organized highway built entirely on numbers. Outside the cabin at 35,000 feet, the world is absolutely deadly. The air pressure is less than 1/4 of what it is at sea level, and the temperature can plunge below minus 60 degrees Fahrenheit. A human exposed to that environment wouldn't survive more than a few seconds. The reason you can sip coffee and watch movies at that height is pressurization. A constant flow of compressed air bled from the engines, pumped into the cabin, and regulated to mimic the pressure you'd feel around 7,000 feet. Your ears pop because your body is adjusting to the cabin's artificial atmosphere. This system creates a breathable bubble of earth inside a metal tube, hurtling through near space. Every breath you take mid-flight is a silent reminder that you're alive in an environment nature never intended you to survive. Planes don't stay at one altitude forever. As fuel burns and the aircraft becomes lighter, pilots gradually climb higher to maintain optimal efficiency. This is called a step climb, and it's one of the most overlooked tactics in aviation. A fully loaded jet leaving the runway might start around 31,000 feet, heavy and slow. But after a few hours, as thousands of gallons of fuel are consumed, the plane can ascend to 35,000 or even 37,000 feet without straining its engines. Each step saves more fuel and boosts range. Airlines program these climbs into flight plans to hit the sweet air, where drag and thrust stay perfectly balanced. It's a dance between weight, altitude, and fuel, executed with precision that saves companies millions over the course of a year. Behind every smooth flight is a hidden equation of dollars and data. A small altitude adjustment, just a few thousand feet, can shift a flight's fuel burn by 2% or more. For an airline, that could mean saving tens of thousands of dollars per trip. Multiply that by hundreds of daily flights, and the savings climb into the millions. Airlines track real-time winds, air density, and temperature to calculate the most efficient cruise level for every route. Lower altitudes mean more drag and turbulence. Higher altitudes strain the engines. The perfect altitude is like a golden ratio where cost, comfort, and control intersect. So when your plane levels off at 35,000 feet, it's not luck. It's an accountant's dream married to an engineer's masterpiece. In the early days of jet travel, planes couldn't soar this high. The Boeing 707 and Douglas DC-8 of the 1950s struggled to reach even 30,000 feet because their engines couldn't handle thin air efficiently. Then came the revolution, the high bypass turbofan engine. This design transformed air travel by delivering more thrust with less fuel, allowing modern aircraft to cruise comfortably around 35,000 to 37,000 feet. Supersonic jets like the Concorde could climb to 60,000 feet, but the fuel costs were astronomical. For today's subsonic airliners, 35,000 feet remains the golden balance between efficiency and endurance, a height where technology, physics, and economics finally agree. Next time you're 7 miles above the Earth, looking down at a blanket of clouds, remember 35,000 feet isn't random. It's where physics, human biology, and financial logic align perfectly. Up there, drag fades, engines hum in harmony, and passengers glide above the chaos below. It's the altitude that defines modern air travel, quiet, calculated, and astonishingly precise. But here's something most people miss. Understanding the hidden science behind everyday things is how we start to see the world differently. So if you found yourself wondering about what really keeps us in the sky, help this channel keep going. Subscribe, hit the like button, and drop a comment with what you want to see next. Every click helps us bring more deep data-driven stories to life, because the more you understand the science above your head, the more fascinating our world becomes.